Just real quick, so I can get a quick show of hands. Who in here are manufacturers? Solution providers? Okay, so there's a little bit of everything in here for you all. One thing we're going to talk about is I co-lead a project called the Digital Thread for Smart Manufacturing at the National Institute of Standards and Technology. Our goal is to develop methodologies, protocols for integrating systems across an entire enterprise to be able to what we are calling, or to create what we are calling a data observatory. And so what you're going to see today is a lot about how we're using the concepts around the industrial Internet of Things to enable enterprise systems to be integrated. And this is talking about taking data from the device control level up through operations into those enterprise levels and being able to see what is happening across the enterprise from any point in the enterprise. So before I really get started, NIST is a government institution or agency, so we've got just a little disclaimer here. You're going to hear me talk about different companies, different products. I'm not endorsing them, and by no way am I actually saying they're the best or fit for purpose. We're looking at many different things, trying to test things out to see what works, and in doing that, we're also trying to look at what is available off the shelf to be able to integrate into our reference architectures and reference implementations. So today, I'll just, one slide on who we are, just to kind of let you all know, if you don't know about NIST, give you some information on that. And then we'll dive in, spend a lot of time on that number 2 there, or the number 2 and 3, on the problem statement and what we are actually doing at NIST. So just some basic facts. One thing I like to point out, and this is probably the only thing I'm going to talk about on this slide, is that we are less than $1 billion agency. But I can tell you everything from your cell phone to how you use your kitchen to everything in your house probably traces back some way, one shape or another, to NIST. We are a measurement agency. We control the standards in the United States around measurement. And so we provide recommendations, how to do measurements. We help produce traceability studies around those measurements. And we're structured in 4 main programs. We have our labs. I come out of the engineering laboratory. Then we also have, for you manufacturers in the room, the Manufacturing Extension Partnership. We also are now working with the NNMI, and we have our Baldrige Performance Excellence Program. So let's really talk about why we're here, what we're trying to do. The digital thread. Out of all the manufacturers in here, how many SMEs do I have? Small, medium enterprises. 1, okay. I'm going to talk directly to you then, because a lot of what the problem statement is, I think, hits the small and medium enterprises more than it does the larger companies. And the reason being is there's this problem with the islands of excellence. We see the problem not only within the domains of engineering, manufacturing, and quality, but you also see it outside the walls of one company, these islands of excellence. So if you are a large OEM and you are going to dictate to your supply chain the types of tools they have to use, remember that those suppliers are probably having other customers or other OEMs they're servicing that may have different tools. And so when we look at inside the walls of an OEM or a large business, we understand that we have IT and OT. And we always hear about the battle between IT and OT in those systems. On the PLM side, which focuses a lot on the engineering information and the information data, you see different tools, these computer-aided technologies. That's the design, the engineering, the manufacturing tools. This is taking that digital artifact, those 3D models, and building those in those systems. And we house those in these PDM systems. Well, the problem with those PDM systems is there's really no standards that drive how those systems interact with one another. And so you have different agents or different organizations within your company who may be on one type of PDM, and then you have another department or organization within your company that's on a different PDM. Trying to move data between those is often difficult. And a lot of times, these systems require lots of customization, especially when you're a large organization trying to deal with different things. And rightfully so, that's because the solution providers are trying to provide as much market share possible to provide coverage over as many markets possible to help their customers be able to do what they want. But then we go over to the operations side where you have the ERP, MES, and SCADA systems, PLC. These also lack the integration across these control levels. And so we heard it this morning about working with MES and having MES do its things and ERP does its things, but when we talk about trying to analyze the different types of data that are housed in these systems, it's very difficult to get that data to move without someone sitting there potentially with a thumb drive or sneaker netting it between these systems to be able to force it in to analyze it in what may be even a third-party system outside those two. So a lot of the work that I'm going to talk about today is focusing on this integration of these heterogeneous systems across this product lifecycle, so that the SMEs in the room, as well as the large organizations, can seamlessly work with their data and, again, curate this, observe it, be able to look at, almost like we do with stargazing with this observatory. I've got a telescope. How do I look at my enterprise and understand what's happening? So why the digital thread? Why the IIoT? We hear about these buzzwords, and I'll be honest, I think we've created kind of a monster in these words and a lot of buzz around them and without a lot of results yet. But I'll tell you, there's a lot of motivation behind what we're actually trying to do in terms of the basic concepts. When we look at across 35 different defense acquisition programs, we always ask why there's so much cost growth. And some of this one particular study found that within the development cost growth, we see about 57% on average growth when you're looking at those development cost growths. And then we see about a 75% growth in the procurement area. And when you look at what's actually the root cause of what most of that cost growth is it comes down to decisions. Either a bad decision was made or the best available solution was made at that particular point in time. But in the end, that decision caused a cost growth. So what organizations are trying to do, or what industry is trying to do, is look at how you can leverage these concepts of the digital thread in the IIoT to say, how can we use digital engineering artifacts? How can we enable our productivity, our quality improvements, our costs, and decrease those costs by using those digital artifacts, such that then we can start analyzing how those artifacts relate to one another and make better decisions. But as we now start pushing this whole talk about digitization and digitize the design, digitize the manufacturing, we're seeing now that there's also a lack of format standards. So we're seeing that you have in engineering's using one type of data. Now when they send it off to manufacturing, they can't use it because their systems aren't able to read that data. And so we're also seeing a lot of the standards in the product lifecycle to compete with one another. So we've got visualization tools. There's 3 or 4 standards now in ISO that all claim to do the same thing. The question is that a lot of industries ask is, which one do I use? They're all standards. Everybody tells me go standards-based. Now I have 3 standards within one development SDO that says these all do the same thing. So we're seeing this rush to get out to the digital thread and provide results because people want them, but in doing so, we're creating confusion by having multiple data formats without having any practice standards or any lifecycle information standards to support this digital shift. So, the digital thread revolution, what are we really doing here at NIST? Before we kind of get into the nitty-gritty of some of our framework that we're proposing, really want to define what the digital thread is to us at NIST. You heard GE talk about their digital thread. In essence, the most general way to look at the digital thread from our perspective is we have one piece of information that can feed the entire life cycle. That's interconnected, linked data across the full life cycle. So if you play the video for me, hit the play button for me on the video, kind of show you a little bit of what we're talking about from design to manufacturing. And so the digital thread we look at as a way that these different machines in the manufacturing process can all follow the same set of instructions or digital instructions. So we can catch those deviations, hopefully automatically, which then we can ensure that this product that was originally designed is what actually comes out of the backside of the system. I put in a digital model in the cyberspace, and in the physical space, I get exactly what I intended to put or get out as my output in that system. So we are looking at the digital thread and the development of standards and technology around that really as a systems engineering problem. It's what are my inputs into this system, and how do those transform into outputs? So when we talk about the work that we're doing at NIST, we really look at the information as these threads again across the life cycle. And the project that I co-lead is part of the overall, or a larger program called the Smart Manufacturing Operations Planning and Control Program. It's a mouthful. Within this program, though, what we're looking at is we want to understand how does that data within these domains as black boxes from a systems perspective, how does that information, if I look at the boundaries of each of these being a system, how does that information flow within its system? There's a lot of work that's been done in the past on understanding this. And so we're trying to do a survey of what's happening, what's out there in terms of standards, how are people doing that. Here we're looking at automation control, those types of activities, understand what is the state of the art. But from that, we want to then understand how do we take the inputs and outputs of each of these functions or systems, and how does that all relate to one another such that we can then start moving information between those systems from either in a linear phase to phase or from inspection all the way back to design in this concept. So a lot of what I'm going to talk about today is we're taking the life cycle and we're shrinking it for the purposes of our research. And again, NIST being a research institute, we are focused on TRLs 1 to 4, technology readiness levels 1 to 4. It's fundamental in applied research. So our goal with a lot of what I'm showing you or going to talk about today is to provide prototypes. And we're putting out open source software, we're putting out technologies on GitHub and other places where people can take that, and we're working on tech transfer into industry to be able to commercialize these. But I'm not going to have a product here at the end of my research to say, hey, go do this. Our goal, though, is in the next 3 to 5 years, you will have a product that will do everything that we're talking about today. So the way we're structured within our program is we want to look at the digital thread across this shortened life cycle. And again, we drew the boundaries of the life cycle from design through the delivery of product to market, because we look at also the support or the sustainment of that product to using the 80-20 rule, that 80% of the sustainment of that product is very similar to what we do in fabrication and inspection. When you're going to do mill or machine replacements or fixed parts, a lot of that data, the type of data that you're going to be collecting, the types of machines you're going to be using to do that overall, you can collect the same type of data that we're doing in fabrication. So for our scope of the project, which runs through FY18, we're focusing on this piece. That's the digital thread here that can link all this together. And so the program's structured in 5 parts. Again, I'm co-leading the digital thread, but we also have a wireless platforms project which looks at how can we deploy wireless technologies out to the shop using the various different standards that are out there. It's everything from your standard just 802.11 Wi-Fi over to more of the industrial implementations. We have a cybersecurity portion that's looking at industrial systems. Keith's over here. If you have any questions about cybersecurity, I'm going to hand you off to him to talk to him about that. The way we look at this, though, in terms of the program, is we look at these 3 portions really being kind of the infrastructure portions of the program. And so the digital thread, again, building the methods, the protocols, reference architecture, and implementation of how to move all this information, will then be able to support these other 2 projects, which is the prognosis, health management, and control project. This is looking at how do I do predictive monitoring or predictive maintenance on my machines. When do I know when to do that predictive maintenance? How can I monitor my system and be able to apply control theory to that? And then the last project is around the systems analysis integration. This is how do I take discrete event simulation or discrete manufacturing simulation and link that to system models, SysML models, so that I have a virtual factory that I can then also use my simulation tools to run discrete events through that system model and be able to use the system models to quickly modularize our factory so that we can use plug-and-play sort of modules to quickly build simulations and virtual factories. So, there we go. So really, in essence, the whole program, more so around the digital thread in itself, is about information sharing across this. And we look at if we can share this information, link it, allow you all to be able to observe the data, you're then able to improve your overall performance of not only the product design, but the processes. And so we are looking at how do you help build better products And through building that better product, as a result, having to build better processes or be able to monitor those processes better, which then gives you, again, that better product. So we're really focused on the product, using the product data to be able to drive control methodologies through the entire life cycle, using quality data and such to be able to then feed back. So here's an idea of our proposed framework around this. We're calling this the Lifecycle Information Framework. And we've broken it out into kind of 3 categories. The top box, they would look familiar to a lot of people who understand PLM. This is your product lifecycle data. This is the design, analysis data, manufacturing data, your customer product support data. This is data that lives out there already today. The problem with it, though, today is that these repositories of where this data sits typically aren't connected in any efficient way, in somewhat not even an effective way. Design and analysis may share that system. Manufacturing may have some gateway between their system and the design and analysis systems, but it's very difficult to move that information. So what happens today is this information that's in the design system tends to become a copy over in the manufacturing system so that manufacturing can do their work. And then you have quality, which just has filing cabinets upon filing cabinets of paper. And so what we want to understand is how can we start looking at this as a linked data problem to be able to link all of these systems together so that the data can then be able to be shared or understood and found and discovered. But before we can, or after we link that data, before we can actually really start taking advantage of that linked data, we have to understand, can we trust the data? And so this is where our second layer comes in, which is around this whole data certification and traceability. What we want to understand is, can we use cryptographic services, things like X509 standard, which is all of your standard SSL certificates and digital signatures. Can we use that type of technology? It's been on the web for many years, doing really well. Can we use that in a manufacturing sense so that we can understand who did what to whom and when they did it? And that allows us to be able to trace what happened or whose the data is coming from. Is that data what it says it is, and how can that data be used? A piece we're adding to that, though, also is the whole concept around data quality. We understand, is the product good enough for production manufacturing? Is the data that was exchanged to you, how is that data collected? Is it actually usable for what you want to use it for? Once we understand how to link the data together and we can trust the data, then we can really start talking about data-driven applications, which I think is where a lot of people are very interested. And I'm going to back up and say, unfortunately, we do a lot of this today without thinking about this. And so we're building out the infrastructure around this at NIST to be able to demonstrate a standards-based approach in an open framework that you could then be able to do what you're doing today in a more trustable way and efficient and effective way. Some of the things that we're looking at, though, is we really want to understand knowledge. How can I build domain-specific knowledge for what I need to do based on the data across the life cycle? So I come from a design world. I spent almost 10 years in the private sector in the aerospace. And as a designer or design engineer, I'd work at a company, and the first thing they do is put you in a room and give me about 3 stacks of binders this big and say, this is our design manual. Have fun. And so you go through this, and it tells you how to design a fillet, how to design a hole, all that fun stuff. And whenever they wanted to update that, they would take a page out of there and say, okay, in 2 years, we'll get this page updated. That was their actual timetable. To update that page is in 2 years. And this is pretty common across aerospace. It takes a very long time to be able to do that, and especially when you're a larger organization, because you've got to say, okay, all those updates, does that work for everybody? What we want to understand is how can we use the data from, if I'm in design, use analysis, manufacturing, quality, and customer support data to be able to start doing machine learning, looking at trends, looking at different things to say, this is how you design a fillet. We want to say, don't do something at 0.2 inches, do it at 0.25 inches, and then actually tell them the reason why you want to do this, because that's standard tooling. A lot of engineers don't understand standard tooling until a manufacturer or an operator has called them down to the shop floor and thrown the part at them. And so what we want to understand is how can we start using data in these different domains and actually feed it back into the design system. Or if I'm in manufacturing, how can I start building on what has caused quality defects based on the way parts are designed, start building knowledge around that to have a manufacturing knowledge base that can help the operator understand the best way to machine a part. And the reason we're doing this is because in the next 5 to 10 years, we're going to be losing a lot of our knowledge. People are going to be retiring. People with 40 years of experience are going to be gone almost overnight. And so what we want to understand is how do we start taking Bob and Larry and all the guys working on the shop floor or all the guys that are buried under paper in their cubicles that they've been gathering for 40 years, how do we take their knowledge and put it in a box so that that fresh green engineer can then have a resource when Bob and Larry aren't around anymore to ask them in person, we can go to the digital Bob and Larry and be able to get an answer. And so that knowledge, we hope, would then be able to start feeding the decision support. Again, it's all about decisions, right? We want to say we're going to reduce our cost by being able to understand how do we make better decisions. Well, I've got to be able to link that data, be able to trust the data, build knowledge on it, so then I can then start making decisions. So we're going to be looking at applications around decision support, management, requirements management. Everybody's got requirements. Unfortunately, they're different throughout the life cycle. Engineering's got theirs, manufacturing's got theirs, and a lot of times they clash. So we want to understand as we, again, link the data, trust it, build knowledge, make decisions, how do those all relate to the requirements? Is the decision meeting the requirements? Are we doing what we said we were going to do or we have to do? And throughout that whole process, we want to be able to diagnose prognosis, or bring prognosis into it, and control the whole activity. So this is a big, hairy, audacious goal. I'm seeing a lot of people looking at me like, you're crazy, you're not going to do this. Well, the thing that we're going to look at is, I'm going to say, by the end of FY18, we're going to have a demonstration capability that's going to show all of this. And we are well on our way. This box here actually is almost done. You can go on GitHub and get some of the toolkits that we're doing there. We're building this all out, and these pieces are in work as we speak. So it's a lot closer than what your eyes are all telling me right now. But just trust me that in the sense that this isn't just paper. This isn't us being academics publishing something in a journal on what would or could happen. We're actually putting our money where the mouth is and actually going to demonstrate this whole capability. So what are some of the objectives of this? I think this first bullet, I want to spend just a few minutes on and kind of get on my soapbox a little bit. Talk about this whole big data, data analytics, all this sort of things. Who can define big for me? This is a rhetorical question, of course, but a big to a GE is completely different than a big to a small 50-person shop. And so we talk about big data, collecting lots and lots of data and storing it in the cloud, which, by the way, is just someone else's computer. We're talking about collecting all these things. And in essence, what we're really telling people to do is collect all this data, and when you have a question, hopefully there's an answer in that data. But really, no one ever stops and asks, what's the question we should be asking in the first place? And so what we want to say, we want to look at is through our research, we want to look at how can we fuse these appropriate data sources into a context with this process-related information. That is, there's two pieces to that bullet. The first half is knowing just the right question to ask. Should I be collecting energy data? Should I be collecting vibration data on a spindle, or should I be collecting it on a case? What type of information do I need to be collecting? And then the other half of it is just knowing how to make those decisions in the appropriate context with the appropriate size of data. And so what we hope to do at NIST is not to redefine big data or any of those things. What we're really hoping, though, is to be able to provide some guidelines such that you can then be able to start understanding what types of decisions are you making, and in those decisions, what do we recommend are the appropriate data sources, the appropriate data sizes to be able to run some type of analysis to be able to make the decision you want. In order to do that, though, we have to be able to ensure that we can manage all of this data across an enterprise. So this one here is the big, hairy, audacious goal part of it. It's really think an integrated ISA 95 model, combine that with a PLM model, and make it all work with universal plug and play. I'm seeing people kind of like, yeah, good luck. That is where we're heading. By the end of FY18, I'm not going to have something that you're going to be able to throw on your production environment, but I think you hopefully have something you can start looking at in your R&D environments and say, hey, maybe these on something, maybe something's going to work. But we really do believe in order to start making these using process-related information and putting them into the right contextual spaces to be able to make those decisions, you're going to need this. And it's not going to be, well, we're going to have this platform over here that's an MES platform, and we're going to have this platform over here that's a PLM or PDM platform, and you're just going to have to make a copy from this to that. That's not going to work. It doesn't work today, didn't work yesterday, and it's not going to work tomorrow. And so this overall data management we think is going to be very important. And again, I'm not up here to say what systems you should use. You should use cloud, or you should use this platform, or go a homogeneous system across the whole enterprise. We're not up here. What we're actually going to advocate through our technologies and through this framework is use what works for you. But we're going to help provide some technologies, or at least start down that technology path to be able to start linking everything together, plugging it in. The other portion of, or the other objectives in this really is to ensure that quality of the data in near real time. So we want to look at how do you do V&V. ASTM, ASME, they're all now starting up some V&V standards to look at how do we do verification and validation of models. Everybody's talking about this whole data analytics thing, but no one's really talking about who's validating the models, how do we validate those models, how do we ensure that this validated model was validated the same way as this other one, and that those two things are giving us the output. So we really do think standards around V&V, around those models, is going to be important. The other thing we want to look at is, are we capable of handling the variety of computational powers with the appropriate data volumes? This goes back to the first data point. Big to GE is not the same as big to a 50-person shop. Not only that, GE can afford high-performance computing centers. That shop cannot. So what we want to understand is how do you make this appropriate, what is an appropriate data volume? What do we consider a large range? But really, how do we make this all scalable such that a small business with, again, 50 people can have the same sort of capability as a GE, who within both of those have two completely different temporal scales. And lastly, it ties into all of this. Everything we want to do, we want to make sure that's extensible. We want to make sure that these new technologies, the standards, they can scale everything from that small shop up to the large enterprises, because it doesn't do us any good to have a framework if it only works for one person. So, getting near the end here, let's talk about the use case. The use case, really what we're looking at is we want to say, take this framework and apply it to a couple of use cases to demonstrate the capability of what we think and show that this is feasible. That's our job. So what we're looking at is we are abstracting the framework out into 4 layers. We're looking at the process layer. This is what everybody's probably familiar with. We have some practices. Here we're very interested in model-based enterprise. That's using models to drive the entire process through the life cycle. Look at the standards around those practices, feeding into design, throw it over the wall to manufacturing, throw it over the wall to quality. That's what happens today. We want to look at that state of the art, look at what gaps may remain there, what needs to happen there, such that then we can start looking at the product data. We want to look at the product data, though, as a cyber-physical system. We want to understand as design builds a CAD model in the virtual space, and we deliver product in the physical space to the market, how can we represent the physical part to be able to then look at relating it back to the virtual? So we want to take the CAD models, look at how those can then be linked to CAM models, computer-aided manufacturing models, look at how we can use MT Connect to get process parameters, process data, monitoring data out of both manufacturing and quality tools. This piece here hasn't been done yet, but I'll tell you, AMT and the MT Connect Institute is working on it, and we're helping them do that. Apply MT Connect to CMMs, to quality machines, to be able to get similar data that we do out of manufacturing tools. And then represent it all in the quality information framework. Just real quick, show of hands, who knows what the quality information framework is? Okay, 2 people. Go to just type in DMSC QIF into Google. Long story short, it's a way to use XML to represent your quality reports. So everything you collect today in an AS9102 form or a PPAP process, they now have a way to make it all computable. And so we're using that to be able to feed that through into this dynamic common elements model, which is now our information model to drive knowledge. We're doing two types of decisions, one into design, one into manufacturing. We want to look at how do we automate the engineering change request. I didn't pick that use case. Congress actually told us we have to look at it. So don't look at me crazy when we say we're going to automate the engineering change request. We are told to figure out how to automate the engineering change request. We're also then looking at how we build knowledge around that to use SPC and stream of variation using machine learning through this process to be able to do that. So we have a test bed. Not going to spend a lot of time here. What I do recommend, though, is go grab this paper. This talks a lot about our test bed. The one thing I'm going to mention on the test bed is we're streaming all of our data live. So this whole use case, we're, again, building parts in this, manufacturing them. We have a 20-machine shop at NIST that's completely instrumented. We're going to publish all that data to the web. So if you want real manufacturing data, it's going to be there. We're working with several universities, a couple of the institutes in the NNMI at trying to figure out how we actually build this more, not just to a NIST test bed, but really a network of test beds to be able to network this again, prove out the infrastructure, prove out the architecture, to be able to stream data across an entire enterprise. We have a prototype complete, and we expect full deployment to be in the next actual couple months. Honestly, we're waiting for IT to say, yes, we can stream the data. So we're just trying to check all the boxes, but everything really is in place. And once the security experts tell us, yeah, we're okay, we're going to actually flip the switch. So we're not immune to the whole IT, OT, understanding these things. We're dealing with it too, making sure that the government's publishing right data. So, in conclusion, we're looking at providing this enterprise technology and system level perspective across the digital thread. We're looking at all levels, again, device all the way up to enterprise. Our research really is rooted in both standards. We're helping develop new standards, enhance existing standards, and we're building new technology. So everything, again, I showed you, we're actually developing technology around it. It's not just it's not on paper. And then lastly, our success criteria really is realizing this long-held dream of linking all these aspects together. What we're talking about doing is not new. People have been wanting to link this data for a long time, but what we are going to gauge success is that we actually demonstrate the feasibility of doing that, putting our money where our mouth is to be able to go out there and do that. Like we've heard many times this week already, is the open standards, open approach is what we think is the best value. And so we are, again, in our early stages. We're about halfway into the project, but our output through FY18 we think will enable, or we know will enable, an ease deployment of these model-based enterprise and next-generation systems to hopefully bring the smart systems to industry. So, thank you.